Hey, welcome to today's Toolbox Talk. I decided to stop early and do this again because last time I tried to do this, I was covered in crap from welding and grinding and machining parts for the magnetic descender. So this time I'm trying to do it before I get too filthy. Today's topic is going to be spreader bars. Spreader bars, everyone knows, they're used to spread two lines. We're going to go through basics. There's three basic varieties. There's the true spreader, which only creates space between the two lines, and that way force is only on the internal pushing against the spreader bar, it's only in compression. The second type is a spreader lifting bar. It's basically similar to the other, but they normally have plates on the ends so that you hook a shackle, so you make your bridles and you make your performer lines. So you end up with shackles everywhere. It's a rattling noise mess. But that's the second type. And the third type is the old school kind, when I started and what we've had. So they would usually bend a piece of rod stock or steel tubing or aluminum plate, lighten it accordingly. It would have mounting plates in the bottom with holes for shackles to the performer, and it would have a single point here. The difference is these two rely on a bridle out of rope, the Tech 12. This is actually, the strength is from the structure itself because it's a single lifting point. So these cords of the triangle are hard stock. So it requires some strength. Okay, so all these three are the basic spreader bars. The true spreader bar is only in compression. The kind we use, whether it's alley or carbon fiber, are these. It's a tube, removable end plugs. They're O-rings, so you can push them in. You can select your distances, what you need for your spreader bar. Now, why would you use a spreader bar? Well, usually a spreader bar is used because you want to pick up a performer on 2 points, and the main reason for this is they're going to rotate on their axis, forward or reverse, or Superman, or fly, or lay back, or be upside down inverted. So they need to be able to move in this axis in a circle. So you're going to pick a spreader bar that's wide enough to clear their feet, clear their head. The lengths are going to be long enough to keep this out of the way. And that way you've created a 2-point pick on the performer, and they can rotate. Now, sometimes it's more comfortable for a performer to be picked front rear if they're not rotating, but it's a certain move or a certain way of holding them up. So they'll be picked front and back. That way they feel more comfortable. It's very dependent on what you're doing, but typically a spreader bar is used because some form of rotation is going to take place. Now, that's in a fight scene, that's in any number of things. Typically with these bars, you're going to have, on a true spreader bar, it's all rope. You're going to have a bridle on both sides that's going to create the top of the triangle, and I'll show you that here. So you'll have this in essence. Let me rotate these so they're accurate. Okay, so you're going to have a setup that is looking like this. The two lines coming from the bottom of the spreader are going to go to your performer. Now, the one thing you have to remember with all of these with rope is that the lengths at the top of your spreader need to be no less than 60 degrees, okay? It's an equilateral triangle. Whatever the length this bar is, these both have to be the same length. That way you have a 60, 60, 60. That goes back to our Jay Gliram and all our other rigging books. It's a 1-to-1 in weight if you're at 60 degrees. If you go 50, 40, 30, a really flat bridle, you've increased the forces in compression significantly. It's the same as with slings. You don't bridle at less than 60 degrees. So the easy way to remember that is just whatever the length of your bar is how long the top legs of your triangle need to be. Okay, we use these because it's pretty simple. We have laboratory corks we use, and these holes are tapered in these plugs. So what we do is we clamp them on. They go around the line, as you see, and then they're put into the tapered holes and cinched up. And they will hold the bar perfect It will not slip, it will not move. It's quick and easy to balance your bar so when it hangs, it's level, and they're fixed. The reason we do this is because there is no metal shackles, no other points. The problem you have with any time you're adding links to this, meaning if you have two separate lines, two shackles, you have more options for failure. If it's two lines from your lift line to your performer, you have A, redundancy, it's two lines. The only thing this does is hold them apart, it's in compression, and you have less modes of failure. Now we also do this with carbon fiber. We have various lengths, and then a little lubrication. And then you push these in, and they go into the tubing. And it's the same thing. Okay, this is set up for 3 mil. These are your spreader bars. No hardware, no nothing. We do them with this style because I can carry everything from 20 mil or 20 centimeter long lengths up to 1.5 meters lengths pre-cut and add the ends as required because they are O-ringed taper holes and they fit on every bar. So I can change the lengths, whatever I need to do. Now the lengths of your spreader bar is gonna obviously be determined by your performer and what happens. If the person's rotating through, they need to clear. If they're holding a gun, if they're kicking, if they have a sword, you need to create enough room for that performer to move through. But the number one basic form of a spreader bar is a true spreader. It's only in compression. The forces, as the person hangs, are creating compression on the bar. So it only needs to be strong enough to hold the forces from the person, say it's 100 kilos, and if you divide this into triangles, you can calculate the force on compression on the tubing. So you can use what's appropriate. Carbon fiber or aluminum. One note on aluminum, it's super light, it's very thin wall. It's only a few 100 grams more than the carbon fiber, but it also has a better failure mode. It can get dinged, bent, tweaked, smacked against things, and you can see it. And you know that it has plasticity. It's not, if it gets banged against something, it'll get a dent. Whereas carbon fiber has two modes. It's either great, or if it gets struck against the side, it will ping the fiber and it's actually ruined the bar. It loses its integrity. So these are an all or nothing. These have various room for accidents and things hitting walls and things in between. Not that you want to, but sometimes if you have this set up and it's on a stage, it may contact parts of set, it may hit things. This is much more forgiving for that than this. I typically use these for performers, actors, flying, where the lines are just supporting them in two positions rather than hanging them like a sack of laundry from a single point. And usually we use a smaller line because it's less visible for the camera. Okay, that's a typical number one spreader bar. Number two, the spreader lifting bar. It's the same type of bar. The difference is on these end plates, what most people will do, instead of having just like we have the tapered hole, they will have a flat plate here. There will be a flat plate on the end with holes for your bridle and holes to shackle your performer lines to. Normally they are not removable. They are normally riveted or glued into these tubings. A lot of times if this is a welded steel, this may be just a welded tab, top and bottom, that's strong enough to just clip your shackles through. It does work. Its main drawback is you have a lot of hardware. At this, you will have two performer shackles on the bar for these two stingers. You'll have two other shackles here for your bridle, and then you'll have your shackle to your single lift line. This creates a lot of mess and hardware. It's loud. You can always PVC tape them to make them quiet, but it also creates more points of failure. You have multiple shackle pins to worry about. You have multiple lines, multiple bridles. It's not just two simple lines from A to B to the performer. It's 4 lines to accomplish the same task. These also normally on the plates on the ends will have holes so that you can bridle this between two people and puppeteer. So you can, on a pendulum, you can create other movements while they are able to rotate. It has its place, not my favorite due to its drawbacks of amount of hardware, noise, etc. The number 3 style is a lifting bridle or a lifting spreader. And these are old school, usually, like I said, flat plate of aluminum. They're in triangles because we have our 60-60, we have our 60-60, we have our 60-60 on a triangle here, because these cords that are in rope on the other two are now metal of some form. These can be fairly heavy, these can be made to be fairly light. What falls in this category is also, you'll see one that's curved and bent, we call them coat hangers. Same concept, but you're relying on these, on material strength, so they don't fold or bend. What you have here is this cord and this cord are taking the load, and this cord is in compression. So this has to be significantly stronger than these. It has its advantages. We'll get to that. So now you have a spreader bar here, a spreader bar here, a spreader bar here. When to choose them? Well, let's start with saying it's always best to run a bridle. If you see down here, 2 pulleys on a continuous, it can either be a rolling or fixed. Typically, you can also use it through a shackle and create just friction, which makes it technically a rolling, but it's very difficult. And it'll take a little bit of side-to-side movement and not be, if this is a rolling, somebody could get all the way up and literally go upside down in this bridle. So you can limit it instead of having to put limiters in. The best part about this is if you use a 2-line system, you go to your perms, you go to your crane, you go up to your pick points, you've now created stability in this axis, in this plane of movement. So with 2 lines, you go out, you've created stability, the performer can move forward and backward in rotation. And it works very well because we're trying to film this. So with a single line, you have a pendulum. If you have a single line coming to this spreader, they can swing forward and back, they can swing side to side. If you don't want that, then it's a problem. If you want to keep them just rotating in a fight scene, they flip, they kick, they're moving forward, this is a great way to do it. Plus, you don't have any hardware hanging in the air above the performer. This is probably the best way to do it if you know you need a bridle to start with. And whenever we rig it, I tend to always put double pulleys and rig it this way, and you'll find out why in a minute. It's the most stable, it gives the most predictable results, it's the addition of another pulley, which makes no difference. It's the nice, clean way to not have hardware flying around on set. Because on sets you have ceiling pieces, you have props, you have things in the air, you have multi-floored interior sets where you're jumping and moving below, the spreader bar is hanging up above and it's running into the railing on the 2nd floor that's in the set above you. These things are a problem. You don't want to do that. So I always rig this way first. With every plus comes a minus. Rigging this way, you end up with a height limitation due to the flattening of your bridle. As you go higher, the bridle gets flatter. That means whatever your weight, performer, on your line is, gets heavier. If this is a hand pull, and you have 110, 100 kilo, 120 kilo person pulling, not really a problem till it gets to less than 60 degrees. Now the person's weight is ever increasing, and it becomes a problem. So there's a trade-off. If it's hand pulls, jumps, movements in certain height, and you have enough ceiling height to work with, then you rig this. But realize if you're going to suddenly go 4 meters in the air with this, you have to have enough ceiling height so your bridles don't flatten out and increase the performer weight. So that is the one thing you have to worry about with this. Now, with this method, you can also clip a true spreader bar to it at this juncture and end up with 2 lines into a single spreader if you want. It will help prevent any movement in this plane because you've stabilized between 2 points in a triangle. So now your performer can rotate, they can move, but they aren't swinging side to side. So in terms of framing for the camera, it becomes much easier for the camera operator. It becomes much easier to pick a path through the movements, and you know what you're going to get. The same with this, if you hook it to this, and the same here. You're at least controlling one plane of movement versus a single line, or a single line. Now that single line, if it comes down from above and it hooks to your spreader, can do any movement. It is not confined. It is a pendulum. Okay? So unless you want that, you now have uncontrollable motion. And when someone jumps, kicks, fights, rotates, it's physics, action and reaction. So if they swing forward to do the motion, the next thing they'll do is swing back. So now the cameraman's chasing them around. If you're in a fight scene, people aren't where they're supposed to be. Things are not stable. So you always try to stabilize it, at least in one plane, which is why these 2 points work really well. Now, an additional factor with single lines versus the double line is if you want not rotation but spin in the vertical axis, ice skater spinning. These will all spin on the single axis. The problem here is if we use a swivel, which most of us use either rocks or petzels, not many people are using circus swivels, at least in stunt world. The problem is they're designed to orient under load. They're not designed to spin a lot under load. So if you put load on them, the problem here was your line will spin before the swivel spins. The single line will spin before the swivel spins. And the same here, single line will spin before the swivel. This creates a problem because Samson with Tech 12 has a call out on how many twists per meter should be allowable before strength reduction. I know this is all moot points, but we always try to do the best possible course. Yes, you probably aren't going to reduce the strength with 4 twists per meter over 10 meters of line, but guess what? It's a call out on Samson, so it's not the best way to do it, okay? So this is what we try to achieve is the best way. So that's why if you want a swivel, then hook it to 2 points and it will allow the swivel to work more because it's between 2 points in a V. The swivel will now work more actively because it's not on a pendulum. It's not winding the line up. With 2 points, it has to swivel. So this becomes much, much more cooperative for swiveling. Now, also understand that with this call out on swivel, if you're up to a single line, every time you swivel, you'll be watching your performer and counting it. You have to untwist them every time to reset. It's just one more step. You can do it, but it's not best practice. We always try to go best practice. In addition, a single point here, this is usually a hole in the top of this solid bar. These bars are much heavier than these. It will wind this line up quite quickly. If it's rigged to a double point, it will swivel on its axis much better. And in fact, because of the weight, the centrifugal force created by the weight, it will spin longer and better than either of these two. So once you get into axial rotation, spinning, think of an ice skater, these bars actually work in your favor because of the weight. Okay? Normally I bolt a swivel to this eye and then to the line, which is in a double, because it will force the swivel to work. It's just a side note on swivels here. With these, I tend to use a bearinged circus swivel, which has Timken style or roller style bearings like you would on a car axle, because it's designed to swivel under load. Okay, not flat bearings like in a Petzl or flat bearings like in a Rock Exotica, because those orient, you'll see them go zhut, zhut, zhut under load till they're comfortable, and they will stay there. They're not designed to do this. Whereas a circus swivel, if you bolt it to this heavier plate, because your force of leverage is off the center by however long this bar is, you're going to create axial rotation, spin. And a performer can actually maintain that spin with body movements and doing, like on the springboard diving, to create spins. And you can get a very nice spin out of these. But it behooves you to rig it to a 2-point bridle, which will help this spin and not just wind up the single line. So those are pretty much the basics of spreader bars. They allow spinning, they allow somersaults or inversions, or they allow your actors to be more comfortable because you've picked from 2 different points. They're not hung, they look better in the air. They don't look like they're on a close hanger. A true spreader bar, only in compression. Spreading lifter bar is in both compression and some force down because your performer is not always equal here. So these plates are going to have to be a little stronger. The bar is typically a little stronger. The ends are usually glued because you're not always creating equal force like here. Here with one line, the only thing you're doing is always your equal forces. Here, you're not. Is it a big deal? No, because these billet plates that everybody builds and drills and glues into these bars is usually more than sufficient strength. The same here. Its forces are both down and not so much in compression because it's a single point. So you're hanging here. This has to support the load. So this, being a solid structure, has to be much stronger than either of these 2 versions. Stronger means heavier. You'll see it in Cirque du Soleil. They'll have a Cirque du Soleil. You'll see they'll have a 1.5 meter long spreader bar, long coat hanger. It's out of welded steel tubing with multiple picks, a circus swivel here, and it might be on a pendulum. The guy's doing big pendulum swings and spins and inversions all at the same time. But that's the result they want. So they know the path on the pendulum. They know what's going to happen, and the weight works to the advantage. It is plenty strong enough at being welded or machined to hold the load with plenty of design factor over the load. So those are your basic spreader bars. I try to keep them as simple as possible, and I've seen everything used from a broomstick taped to a line because nobody has a spreader bar, to pieces of PVC, which turns into a big U shape because under compression it can't hold enough load and it bows. Use the right tool for the job, folks. You got a choice of only in compression. You got a choice here for maybe you need the puppeteer. You need a pendulum to swing back and forth while they do the motion. You can have 2 people on lines moving in that plane as well as the performer here rotating. The main thing to remember is if you're using rope for any of these bridle types on the spreaders, 60 degrees or more. It's an equilateral triangle. You only want equal forces and equal lengths. Anything less than 60 degrees, I always get these backwards. Anything less than 60 degrees, meaning flatter, the bridle flatter than 60, what you end up with is multiplying the load of the weight at the bottom of this into your bridle and adding more force, especially on this bar. It becomes noticeable because you now are flattening this triangle, so you are pulling very heavily against these 2 anchor points. That becomes a problem. At 60 degrees, you're still pretty good with the performer. It balances out more or less to 1-to-1. On this one, if you go flat, you're just adding more and more compression force, only internal compression on this one. So you have to keep your top as an equilateral triangle. In theory, this one doesn't care because you could, if you wanted, have a strong enough piece of metal up here, aluminum, steel, whatever. This could be just an I-beam. You don't even need the top half of this. With an eye on top and eyes on, it doesn't matter because this is what's taking the load. So if it's strong enough to put it all in one piece, you could pick it up from the middle and hang from both ends. It won't bend, but it gets big, it gets heavy. Cranes don't care. You see them lifting air conditioners. You see them doing all that with bars that are basically an I-beam with points lifting a weight. Because we use performers, we try to keep these to a certain useful weight. We don't need that. So they tend to be in this triangular structure or coat hanger structure. So they're trussed like small trusses. You'll get a lot of fancy designs. And sometimes with performers in a performance for circus or for Cirque du Soleil or for whatever, they will become part of the prop for the act. So they will get very fancy. They'll have very whimsical shapes and sizes, but they're always built heavy enough to deal with this. Again, your weight here on a swivel is your friend. And remember, the best way to always rig is to do 2-point bridle. And most of the time for what we do, you won't need a spreader bar. It's a much better way to do it, unless of course you have no access into the set other than a single point, and then you have to split it to 2. Regardless, you just have to make those choices. But this, 9 times out of 10, will solve your spreader bar issue. No hardware, no clatter. So there you go. True spreader, spreader lifting, and a lifting. Remember to always check how many twists are in your rope. Samson has a spec if you look at their rope guide. And use the correct swivel so that you're not just winding up your rope. Okay, folks? That's it. That's the simple spreader bar talk for today. Hope you enjoyed it. And if there's any questions, you can always text, email, whatever. And yeah, enjoy your spreaders. We make kits. It becomes easier to do true spreaders and keep true spreaders. I have some of these that are machined. We take these plugs and instead of a hole, we machine a slot and put a plate in them, and they're bolted in, and we still slide them in and out with O-rings because we know the strengths on all of them. And probably one of these days, I'm going to set up a couple of spreader bars on the brake tester behind me here, and we're going to pull on them and just see what the reality on a true spreader versus a plate spreader is, where they break at. Why not? I've got some extra carbon tubing and some extra alley, and we'll break a few. And that way you'll see what the actual difference is. All right? But that's spreader bars for today. Thanks a lot.